So welcome to another CS341 sample video. What I'm doing here is I'm looking at the optical flow algorithms that we've looked at in lectures, and what I want to do is show them in a situation where they're likely to break down. So we've got lots of camera motion and we're looking at a scene that's kind of got a lot of features in, but it's also got some problems like reflections and some features that don't actually exist on the object but are actually artifacts of the lighting. So that was the input video, and here we've got the output of the dense optical flow. In this, colours represent directions, so when you go in and out you see the colours different all over the edges of the scene, which shows that the points at the edge of the scene are moving in different directions. When you have motion that's in a coherent direction, the colour that's represented, as in the direction that's represented, is the same, and then you get disco cat. With the sparse optical flow methods, this is using lucas-kanade KRT type tracks, there's a different kind of problem, and the problem with the LK methods in situations where the camera moves quickly is that when the tracks go off the edge of the window you have to reinitialize, so you find yourself losing tracks and then gaining tracks. And it's a question of working out when you need to reinitialize. I've just left the default settings here so you can see where it kind of breaks down. And this final section is the same as the previous one, but just without the background. So you can see the motion more clearly, even if you can't quite see what it's pointing at. And again, you see the problem that when the camera moves quickly, you run out of tracks and it needs to reinitialize. And that's that. It's kind of a silly video, but I think it shows something useful about these techniques.